So we have been talking about the bundle conductors in all three phases. So we have looked into these equations. So now let us continue with this. So VC is ZCA to IA dash So that same thing we will add and subtract plus ZCR. I have added ZCA into IR, so I have to subtract then ZCS minus ZCB yes plus ZCT minus ZCC. IT. So then therefore ZCA into IA plus ZCB ZCC into IC plus ZCR minus ZCA to IR plus ZCS minus ZCB to IS ZCT minus ZCC to IT. So this is equation 3. So we have modified equations for VA, VB and VC to connect them with the actual phase A, phase B, phase C currents. Now let us look at the voltage equations. I know that VR minus VA is equal to 0. So I can write down that ZRA minus ZAA into IA dash. Now if I subtract if I now subtract first row from the fourth row and then write down the equation VR minus VA is equal to 0, that is equal to ZRA minus ZAA into IA dash plus ZRB minus ZAB into IB dash ZRB minus ZAB ZRC minus ZAC into IC dash plus Z RR IR ZRR minus ZR IR plus ZAT into IT. Now, so then therefore I can write down 0 is equal to ZRA minus ZA into IA dash plus IR plus ZRB minus ZAB into IB dash plus IS plus ZRC minus ZAC to IC dash plus IT plus ZRR minus ZAR, and now I have also added ZRA minus ZA into IR, so I have to subtract it, so it will be ZRA plus ZAA into IR plus plus ZRS minus ZAS. I have to subtract this because I have added ZRB minus ZAB into IS, so I have to subtract it. So minus ZRB plus ZAB into IS plus ZRT minus ZAT, and then I have added this. So ZRT minus ZAT, and then I have added ZRC minus ZAC, so subtract it, ZRC plus ZAC into IT. That would be the case. So ZRR minus ZAR minus ZRA minus ZAA, then ZRS minus ZAS minus ZRB plus ZRB, and ZRT minus ZAT minus ZRC plus ZAC. Okay. Now let us denote that this quantity to be, say, Z R dash, this quantity to be ZRS dash, and this quantity to be ZRT dash. Let us define it. So then therefore my equation becomes 0 is equal to ZRA minus ZA into IA, because this IA dash plus IR is IA, plus ZRB minus ZAB into IB, ZRC minus ZSC into IC plus ZRR dash ZRS dash dash IT. So this is equation number 4. Similarly, Vs minus Vb is equal to 0. So, Vs minus Vb, if I do, so Vsa minus Vba, Vsj, sorry, Zsa minus Zba, so it is Zsa minus Zba into Ia dash Zsb into Ib dash plus Zsc Bc into Ic dash, then ZSR minus ZBR into IR plus ZSS minus ZBS into IS ZST ZBT into IT. So ZSA minus ZBA, ZSB minus ZBB, ZSC minus ZBC, ZSR minus ZBR, ZSS minus ZBS, and ZST minus ZBT. So therefore, 0 is equal to ZSA minus ZBA into IA dash plus IR plus ZSB minus ZBB IB dash plus IS ZSC minus ZBC into IC dash plus IT, then plus ZSR minus ZBR, ZSR minus ZBR minus ZSA plus ZBA into IR plus ZSS minus ZBS, ZSS minus ZBS, and this I have to ZSB plus ZBB into IS plus ZST minus ZBT, ZST minus ZBT minus ZSC plus ZBC into IT. So let it be ZSR dash, let it be denoted as ZSS dash, let it be denoted as ZST dash. So therefore 0 is equal to So this is equation 5. Lastly, Vt minus Vc is equal to 0. So Vta minus Vca. So Vta minus, sorry, Ta minus Cb into Ip dash plus Z Tc minus Z Cc into Ic dash plus Z dr ZCr into IR plus ZTS IT. So therefore, ZTB minus ZCB into I P dash into IS plus ZTC minus ZCC into IC dash plus IT plus ZTR minus ZCR minus ZTA plus ZTR minus ZCR, ZTR minus ZCR minus ZTA plus ZCAIR plus then ZTS minus ZCS minus ZTB plus ZCB into IS plus ZTT minus ZCT minus ZTC plus ZTT. So ZTM minus ZCA, ZTR, ZTB, then ZTS minus ZCS, then ZTB, ZCB, and then ZTT minus ZCT, then ZTC minus ZCC. So we call it So this I call as Z TR dash. This I call as Z TS dash. This I call Z TT dash. Right, so this I call. So then therefore I can write down last equation 0 is equal to ZTA minus ZCA into IA. Then ZTB minus ZCB into IB plus ZTC minus ZCC IC plus ZTR dash into IR IT. So this is equation 6. Now if I combine equation 1, 2, 3, 4, 5, 6, so I can write down that combining 2, 3, 4, 5 and 6 together. What I can write? I can write VA, VB, VC 0, 0, 0. So VA, VB, VC, then 0, 0, 0. VA is ZA, ZAB, ZAC. ZA, ZAB, ZAC. Where is ZA? ZAR minus ZAA, ZAR minus ZAA. Then ZAS minus ZAB, ZAS minus ZAB, ZAT minus ZAC. Okay, then ZBA, ZBB, ZBC. BR minus BA, ZBR minus ZBA. Then ZBS minus ZBB. Then ZBT minus ZBC. ZCA. ZCR minus ZCA. then ZCS minus ZCB, then ZCT minus ZCC, ZCT, ZCC. It should be ZBT, BT minus ZBC. This is ZBT, sorry, ZCT minus ZCC. Okay. Then 0 ZRA minus ZA, ZRA minus ZA, then ZRB minus ZAB, then ZRC minus ZAC, ZR dot dash, ZR is dash, right. Then equation 5, ZSA minus ZBA, then ZSB minus ZBB, then ZSC minus ZBC, ZSC minus ZBC, then ZSR dash, and then the last equation is ZTA minus ZCA, ZTV minus ZCB, So this is a 6 cross 6 matrix. It has to be a 6 cross 6 matrix because there are 6 equations. So now what we do is we partition this matrix. So like this. And we partition this matrix like this. So I have got one partition here 3 cross 3 matrix, another partition here 3 cross 3 matrix, another partition here 3 cross 3 matrix, another partition here 3 cross 3 matrix. And I call this vector VABC is equal to VA, VB, VC. Then I also call this vector IABC is equal to IA, IB, IC. I call this vector IRST is equal to IR, IS, IT, and I also call another vector 0, big 0 is equal to 0, 0, 0. So these are all, these are 3 cross 1 vector, and I call this big matrix as ZA, 3 cross 3 matrix, this 3 cross 3 matrix as ZB, this 3 cross 3 matrix as ZC, all these are 3 cross 3 matrix, and this 3 cross 3 matrix as ZD. So from this I can write down the following vector matrix equation: VABC is equal to ZA into IABC plus ZB into IRST, and from here I can write 0 is equal to, it's a big 0 matrix, ZC into IABC plus ZD into IRST. So from there I can write down that IRST is equal to minus ZD inverse ZC into IABC. So if I substitute this here, so from here I can write down that VABC is equal to ZA IABC ZB into IABC. So ZB into ZD inverse ZC into IABC. So ZA minus ZB to ZD inverse to ZC to IABC. Or in other words, I can write down that VABC. So this is the final matrix ZABC into IABC, where ZABC is equal to ZA minus ZB ZD inverse ZC. Of course, this kind of calculation requires the help of a computer, but nowadays that is not a big problem. So that's how we can calculate or compute the impedance matrix of a bundle conductor line where every phase has got 2 bundle conductors. Of course, we can extend this principle in case if there are more than 2 bundle conductors in every phase, but of course we are not going to discuss that, because in that case the cases would be endless. But with this very basic concept, we can always extend it to consider any number of bundle conductors in any phase. So we stop here and we will continue with the other aspects of this course in the next lecture. Thank you.